Recently, you would have come across one biggest news. DRDO has new GaN technology and it's boosting India's defense. And what is this GaN technology? And how it is different from silicon technology and how it is replacing silicon technology? For this, let us understand the electrical background of GaN technology. Before going to the breakdown of what is this GaN, we'll understand the application of GaN. Let me start with an example. Most of the semiconductor switches are used, that is converters, and that too in general I'm taking a simplest buck converter. So I'll draw a buck converter circuit. The biggest application of semiconductor switches are their application in converters. So currently a semiconductor material switch is used in this buck converter, and the application of this switches in the buck converter is based on its duty cycle of the operation of the switches will be varying the output of the converter. So if you are increasing the switching frequency or increasing the duty cycle of the switches, the output will be varied. So that is the application of switches in DC-DC converter. Now, what is this GaN or replacement of GaN in current silicon switches? Or this GaN has a very high switching frequency. So we understood the application of GaN, that is its high switching frequency, which will help in converter circuits or any application where switching frequency is directly correlating to the design of the circuit. So that is one advantages of this GaN, and this will play a crucial role in current advancement of technology, because all these converter sizes, if they are getting reduced because of its property of the material of semiconductor used, then this will be the biggest advancement in the technology, and that is what is happening in current automotive world and current automotive world. Now let us understand the semiconductor physics of this GaN. GaN is gallium nitride. How it is advantageous over current silicon semiconductors, I'll explain. First, gallium nitride has two elements, gallium and nitrogen derivative nitride. Gallium is from group 3 metals and nitride is from group 5 metal elements. So group 3 elements has 3 valence electrons, and group 5 elements has 5 valence electron. So gallium has 3 valence electrons and nitrogen has 5 valence electrons. And for gallium, it's as a group 3 metal properties, it is easy to lose last 3 valence electrons, and nitrogen it's easy to gain 3 electrons. So there is a ionic nature of bond formation, and that is what is happening. Gallium will lose 3 electrons and forming Ga3 plus and N3 minus is a stable compound which is getting formed, G gallium nitride. The ionic structure of this compound is the stable form will be in hexagon form. That means three each gallium atom is shared to 3 nitrogen, and each nitrogen is shared to 3 gallium atoms. So it will be like, if I take gallium, and each nitrogen is will be shared to 3 gallium atoms. So this kind of structure will form a hexagonal structure of the compound. So earlier we discussed one advantage, that is switching frequency of gallium nitride is very high. How this property comes, let us understand. Gallium nitride has the bandwidth 3.4 electron volt and silicon has 1.2 electron volt. And silicon carbide, the next advancement technology in silicon carbide, that is having 3.2 electron volt. This bandwidth of gallium nitride is, you can see the number is very high. So how this bandwidth is correlating to the advantage of this gallium nitride, we'll understand. So before that, we'll get a short information on what is this bandwidth and how is this advantages to a semiconductor. Property of elements. So any element in a periodic table will have two things. One is its valence state and conduction state. Conduction state. If the energy bandwidth is very small, this gap is very small, then free electrons can be easily going into conduction state. It can easily jump because of each electrons will have its own energy, and with this energy it can easily jump to conduction state. So if gap is very small, valence electrons can easily go to conduction state. That is the property of metals. Metals have almost zero energy gap, zero electron volt energy gap. Coming to insulators, insulators have a big energy gap, more than 4.4 electron volt, very big energy gap. And to make the free electron from valence state to conduction state, you have to give a lot of energy to make it to jump from valence state to conduction state. So for insulator, it is not at all possible to make this jump. That is why insulators are not conductors, because of this property. Now for semiconductors, this is why is the property of semiconductor so different from conductors and insulators. Semiconductors have a moderate range of energy gap between 0 to 4.4, moderate energy gap. Because of this reason free electrons can jump from conduction state to valence state to conduction and conduction to valence. They can be jumping from two states. And why is this property important? Semi Semiconductors can be used as a switch. Why? If you give a voltage, then it will conduct. If you don't give a voltage, it will not conduct. Then it will act as an insulator. So there is a property to control these semiconductors. So that is the reason these semiconductors will have a variety of application in current electronic world. So now we understood what is this energy gap. Now what is this gallium nitride having that energy gap which is different from silicon, so that is having more advantages, that we'll understand. Gallium nitride, we have energy gap of 3.4 electron volt. If the energy band gap is more, there are two things. If the energy band gap is small, for example for silicon it is 1.2 electron volt. If energy band gap is small, free electron sometimes what happens, uh, will move from conduction state to valence state to conduction state, and create, once they are jumping from valence state to conduction state, there will be a generation of hole. There will be a generation of hole. Once this hole is getting generated, sometimes this hole also can move from valence state to conduction state whenever the movement is from other way around. Because of this reason, there will be a leakage current from that semiconductor. Means if you want to drive the current in one direction, there will be again opposite current which will be generated because of this reason. If the energy band gap is little more, which is 3 point, like for a gallium nitride it is 3.4 electron volt, then the conduction will happen only if some voltage is applied between the semiconductor, and for that reason only majority charge carriers will jump from one state to another state. There will be no minority carriers which will be conducting. So gallium nitride will have almost zero leakage current. And so how this bandwidth is correlating to switching frequency, that will understand. If bandwidth is more, then the leakage current will be reduced. If leakage current is reduced, then it is, that means you are increasing the majority carriers concentration. If majority carrier concentration is increased, that means it takes little time to conduct the electrons from valence state to conduction state and conduction state to valence state. So that is one bigger advantage that is correlating to directly to your switching frequency. So this is the advantage of this gallium nitride. Gallium nitride has higher bandwidth, energy bandwidth, that is correlating to higher majority concentration, that is correlating to higher switching frequency. So this is the reason gallium nitride is the current. This is the reason gallium nitride is the current semiconductor advancement in all automotive or any defense application, and that is what India also want to do. Before this, India was not in this gallium nitride technology. Recently, DRDO DRDO has made its first gallium nitride chips. So that's it for today. If you find these kind of videos interesting, please subscribe the channel and encourage me to do much more videos. Thanks for watching.